All right, let's talk about Kubernetes. You've probably heard of it. It's the powerhouse behind basically every major app you use. But we're not going to just read some dry documentation today. No, we are going to walk through a real production-ready setup and make it so simple that anyone can get it. Have you ever really stopped to think about how an app like Netflix or Spotify can handle millions of people all hitting play at the exact same moment without completely falling apart? I mean, it's not like they have one single gigantic supercomputer somewhere. The secret sauce is a little something called orchestration, and it's all about managing thousands of little moving parts flawlessly. Okay, to make this all make sense, we're going to use an analogy. So for the next few minutes, I want you to forget all about servers and code and all that tech jargon. Instead, you and we're going to build and run a restaurant, a really high-tech one. And I promise, by the end of this, you'll be able to look at a complex Kubernetes file and read it as easily as a dinner menu. First things first, every restaurant needs a place to set up shop, right? We need to claim our little corner of the world. Think of the entire Kubernetes system as a giant food court. A namespace is your own designated spot in that food court. It's like putting up invisible walls that keep your kitchen, your staff, and your customers completely separate from the taco stand next door. This is so important for keeping everything organized and making sure apps don't step on each other's toes. All right, we've got our space. Now for the heart of the operation, the kitchen. This is where all the magic happens. So meet your restaurant manager. In Kubernetes, this is called a deployment. And the manager has one single-minded job: to look at the master work schedule and make sure the kitchen is staffed exactly right. Not one chef more, not one chef less. And what does our schedule say? It says we need 6 chefs on the clock at all times. In the Kubernetes world, these chefs are called pods. They're the smallest, most basic units that are actually doing the work, running our application. So our manager, the deployment, is just constantly counting heads to make sure we always have exactly 6 pods running. Now, this is really crucial. We have to manage what our chefs are using. Each chef needs a certain minimum amount of ingredients just to get started, right? In Kubernetes, that's a request. But their station can only hold so much stuff before it becomes a total mess. That's a limit. And here's the clever part. If one chef goes rogue and starts grabbing way too many ingredients, using too much CPU or memory, their whole station just gets shut down and replaced instantly. It prevents one problem from taking down the whole kitchen. So how does the manager know if a chef is actually doing okay? It performs health checks. Let's say a chef starts getting really sluggish, falling behind on orders. A readiness probe will fail. This tells the system, hey, this chef needs a minute to catch their breath. Stop sending them new orders. But what if the chef just faints, totally unresponsive? Well, then a liveness probe fails, and the manager doesn't hesitate. They send in a fresh replacement chef immediately. It's a 2-level system to keep things running smoothly. And here's another pro tip for reliability. You would never cram all your best chefs into one tiny corner of the kitchen, would you? Of course not. If the power went out in just that one corner, your entire restaurant would grind to a halt. Topology spread is just a rule that tells Kubernetes to spread your pods, your chefs, out across different physical machines. That way, one server failing won't take down your whole app. Okay, the kitchen is humming, the chefs are ready. It is time to unlock the doors and let the customers roll in. Inside the restaurant, we have the service. You can think of this as our internal waiter. This waiter has one stable phone number that anyone inside the kitchen can call to place an order. And when an order comes in, the waiter doesn't care which chef takes it. They just find any chef who's free and gives them the order. It's basically a load balancer for all the internal communication. But how do customers from the outside world even place an order? They talk to the host at the front counter. And that is our ingress. The ingress is the public face of our restaurant. It's the single web address that all traffic from the internet hits first. It then knows exactly how to route those orders to the right internal waiter. So our restaurant is a hit. People love it. But now for the real challenge, handling the lunch rush. Let's see how our automated system deals with a massive flood of new customers. And here we go. It's 12 o'clock sharp. The floodgates open. The line is suddenly out the door. Orders are pouring in, and our 6 little chefs are starting to look pretty stressed out. We can see the problem right on the monitors. The average workload for our chefs, their CPU usage, has just spiked to 90%. That is way above our target of 80%. They are completely overwhelmed. If we don't do something and do it fast, the whole system is going to slow to a crawl. But we have a secret weapon. the shift manager. In Kubernetes, this is called the Horizontal Pod Autoscaler, or just HPA. The HPA's only job is to watch the chef's workload. And the very second it sees them cross that 80% line, it picks up the phone and calls for reinforcements. And just like that, backup arrives. The HPA tells the deployment manager, hey, we need more chefs stat. And the number of running pods, our chefs, instantly scales up from our minimum of 6 to 8. If the rush gets even crazier, it'll scale all the way up to our max of 10. Then, when things quiet down, it'll scale back down to 6 to save us money. All of this happens in seconds, and not a single human has to lift a finger. The lunch rush is over, everything went off without a hitch. Now let's bring it all home and see how this connects back to that intimidating-looking configuration file from the beginning. This right here is the big takeaway. That entire awesome self-healing restaurant system is defined in one single blueprint, a YAML file. It describes the restaurant manager, which is the deployment, the internal waiter, our service, the front desk host, the ingress, and that amazing shift manager, the HPA. It is all right there in one file. And now you know how to read it. And you know what the best part is? This restaurant blueprint we just built, it's not some simplified toy example. If you get this analogy, you genuinely understand about 80% of how huge real-world apps are deployed on Kubernetes right now. The concepts are exactly the same. So you've just walked through how to design a system that's strong, that can scale up and down on its own, and can even heal itself. You have the core concepts down. So really, the only question left is,